In this video, we're going to see how to use row operations to simplify our determinant calculations. So to compute the determinant of this 3 by 3 matrix, we might look at this and notice that the first row is entirely divisible by 2. So we might think that dividing the first row by 2 is going to simplify our calculations. So really what we want to do is think about a multiplication operation that is going to encompass this. So really what we would like to do, let me just write the second row as the same here. We want to think about dividing that first row by 2, or maybe another way to say that is factoring a 2 out of there, so that we'd really like this to be a 1, 2, and a 3. Now in order to make this the same as what we had before, we're factoring that 2 out, we're really multiplying this by a matrix that multiplies the first row by 2. And we can quickly check that the product of these two matrices is the original one. Now we know that the determinant of a product is a product of the determinant, so we can quickly compute the determinant of our diagonal matrix over here, which we know to be 2. And this will just be 2 times the determinant of the simplet matrix. 1, 2, 3, 1, 0, 3, and 0, 3, 4. Now, as you get more proficient at this, you won't need to write down this intermediate step every single time. You can just jump straight from the first one to the third one where you factor that 2 out. But in this video, I wanted to write it down explicitly so we can see exactly what's going on. Now, the next thing we might want to try and do is look at this first column and see that if we subtracted, say, the first row from the second row, then our first column would just be a standard basis vector. So in this case, we want to do the same kind of thing and write this as a product of 2 matrices. And so the result, we want to leave the first row and the third row alone, 0, 3, 4, and we want to subtract that first row from the second row, which would leave us with a 0 and a -2 and a 0. So interpreting that as a matrix multiplication, let's see, to make these the same, we would have to have a positive one here as the inverse of that subtraction operation. Now the good news is this matrix on the left has a determinant of 1 because it's representing that shearing operation. So we just end up with 2 times the determinant of 1, 2, 3, 0, -2, 0, and 0, 3, 4. And again, as soon as you start doing a few of these, you're going to be skipping this intermediate step here. So in general, what we might try and do is write down determinant of 2, 4, 6, 1, 0, 3, 0, 3, 4. We would factor that 2 out of the first row, like this. So we'd have 1, 2, 3, 1, 0, 3, 0, 3, 4. And then we would just do that row operation that we know does not alter the determinant. So our first and third row are the same, and then we would have a 0, a -2, and a 0. So again, what's written in blue here is absolutely okay. And then what we did in black was just kind of the very detailed reasoning to go along with all of that.